Bright Tuty. Every student matters.
Hello students, so we will continue our chapter square and square roots. What we are going to do in today's section is a lot of practice questions, and we're already done with the properties, the patterns, and we have reached on to some very important conclusions. Now we are going to apply those properties and conclusions to the questions now. Just to see here is the first question. It is asking what will be the unit digit of the squares of the following numbers. And the numbers are 81, 272, 799 like this. So we know that how do we find the unit digit in the square of any number. So we know if a is any natural number, if a is any natural number, or we say it is including 0 also, I say whole number, right? So then the square, then its square. We know that if the unit digit in any of the number is a, if a is the unit digit, right, then in the square of that number, the unit digit in the square of that number will be given by a multiplied with a. Right, that means what we are doing, a is the unit digit, let it be of any number. If a is unit digit of any number, then the unit digit in its square will be given by a cross a. In question number 81, right, first part 81. Okay, if we do the square of 81, just observe the unit digit of 81. What is it? 1. So you are going to do the square of 1, it gives you 1. So the unit digit is 1 in the square of 81. Second part is 272 whole square. Correct? What is the unit digit in 272? 2. You have to do the square of 2 and it gives you 4. So the last digit, or I say the ending digit, the units digit in the square of 272 will be 4. In the third part, similarly, we have to attempt all the parts. 799 whole square. What is the unit digit here? 9. Square of 9 is 81. So what will be the unit digit? Here the unit digit will be 1. Clear? In the fourth part, you see we have 3853. If we do the square, right, what is the number at units place, or what is the digit at units place? 3. Square of 3 will be 9. So in the square of 3853, the unit digit will be 9. Fifth part, it is 1234. 1234. In the square of it, what will be the unit digit? What is the unit digit here? 4. Square of 4 gives us 16. So 6 will be the unit digit in the square of 1234. So what we are doing actually, we are just finding out the square of the unit digit, and whatever the digit at last we are getting of that number, we are writing that as the unit digit of that number. Now I think, see, you can attempt question number 6 also. Sixth is 26387 whole square. So 7 is the last unit, or I said unit digit. So 7 square will be 49. So we get 9, right? So 9 is the unit digit in the square of this number. Seventh part, we have 52,698. Its whole square is there. So we see that last digit is 8. Square of 8 gives us 64. So in the square of this number, the unit digit will be 4. Right? Now let us do the 8th part. In the 8th part, we have 99880. Right? So in the square of this number, unit digit is 0. So 0 square will be 0. Right? So we are going to get 0 at the end of this square of 99,880. So the unit digit in the square of this number is 0. Ninth part, we have 12,796. Going to do the square of it. What is the last digit here? 6. Square of 6 gives us 36. So the unit digit in the square of 12,796 is 6. Last part, which is the 10th part, it is given as 55,555. If we do the square of it, we know if a number ends with digit 5, the square of it will also end with digit 5. Square of 5 gives us 25. So the last unit digit, the last digit, or we say ending digit, or the unit digit will be 5 in this case, right? So I hope this question is clear to you. So what we have done, whenever it is asked in the question that you have to find the unit digit of the square of the following number, right? We know the unit digit of all of these number which are given to us. We just need to do the square of unit digit, right? So if we do the square of 1, we got 1. When we were doing the square of 4, we got 16. So out of 16, you just have to take 6, the last digit. That becomes the unit digit for the square of these following numbers, right? I hope the question is clear. Let us move ahead. See, here is another question. They're asking the following numbers are obviously not perfect square, give reason. So they have already declared that these are not perfect squares, right? We have to give the reason. So how do we check what we have learnt about the property of perfect square? That a perfect square ends with or does not end with, okay, because we have to tell these are not perfect squares. So let us go with does not end with. So perfect squares does not end with, what are the digits that the square numbers, perfect square number does not end with is, they do not end with 2, 3, 7, 8 and odd number of zeros. Clear? These are the things that we need to keep in mind. So in the first one, 1057, what is, this is a square. They are saying these are not perfectly square and we have to tell why. So we see the ending digit is what? We will write ends with digit 7, right? So what is the reason that it is not a perfect square? Because it is ending with digit 7. There is no perfect square that ends with 7, right? Similarly, in the next part, the ending digit is 3. Hence, it is not a perfect square. In the next part, can you think of the reason? Just say, think about it. The unit digit here is 8, right? No perfect square number have the ending digit as 8. So this is not a perfect square because it ends with 8. Now this one, this is ending with 2. So it is not a perfect square. We have already written these 4 digits. These should not be there. An odd number of zeros at the end should not be there. Now here 64,000, we see there are odd number of zeros at the end. So it is not a perfect square. This is ending with 2. So it is not a perfect square. The next one have odd number of zeros, not a perfect square. And the last one also have odd number of zeros, right? So if we have odd number of zeros at the end, or else we have 2, 3, 7, 8 as the ending digit of any number, we can directly say that they are not perfect squares. Clear? Let's move ahead now. Here is one more question. It is asking the squares of which of the following would be odd numbers. That means the square of, we are going to do the square of these numbers and which square is going to come out as odd. Now we know one property. The property is square of, you may write this in the starting of the question and then give reason for each. So you will write square of an odd number is always odd, right? And square of an even number is always even, right? This is what we know. Now first one is 431, right? So the square of which of the following would be odd number? 431 is even or odd? You will write it is an odd number, right? So its square will also be an odd number. Is that clear? This is how you write the statement. Second one is 2826. This is what? Even number, right? So square is also even, right? Now the third one we have, in the third we have 7779. It is an odd number, so square is odd, right? Square is also odd. The fourth part you see 82,004, 82,004 we have even, this is an even number, right? So square of 82,004 is also even. This is how we write the statements, the reasons, and identify the numbers whose square will be odd, whose square will be even. This is really simple to remember that if the number is odd, the square will be odd. If the number is even, the square will be even. Clear? I hope this is giving you more clarity on properties, how to use the properties in the questions, right? Let's move ahead now. Here is the one beautiful pattern given to you. They're asking observe the following pattern and find the missing digits. So you just have to, find the connection, find the pattern that is formed here, I would say, the relationship between the digits, the places and the digits, and then we can know what can be filled in the boxes or in the blanks left. Just see here. You see in everyone, what is the common thing that we see? We see that first digit and the last digit, starting and ending digit are 1 and 1. So we know that in the answer we just have to write 1 and 1 at the first and the second place, that's for sure. Now the middle term is 2 here. Here also the middle term is 2. Here also middle term is 2. Here also middle term is 2. So here also the middle term will be 2. That is clear. The middle term is 2. What about the number of zeros that are added here? So see, in 11 there is no 0. So we just have 1 to 1 is the answer. In 101, how many zeros? 1 0. So what you will do, you will add 1 0. 121 was the first one, and 101, because we are inserting 1 0 between these two digits. What we will do between these two digits? We will insert 1 0. Between these two digits, we will insert 1 0. Right? So we have got this. Now in the next one there are two zeros. So between 1, 2 and 1, we will insert two zeros on both the places. Now here how many zeros do we have? 1, 2, 3, 4. So 1, 2, 3, 4. Right? 1, 2, 3, 4. Like this we insert the zeros. Now we have written the first digit and last digit because here nothing is given. So first digit is written, last is written. We know that the middle term will always be 2. That is also written. How many zeros do we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Whatever the number of zeros is given here in the question, in the number whose square we are taking, in the square of that number, those many zeros will be added between 1 and 2 and 2 and 1 respectively. Clear? I hope that this is something very interesting or a beautiful pattern that is given and formed with the numbers, and then we can directly write the squares of those number. Otherwise calculating manually the square of this number would have taken a lot of time. So directly we have written the answers. Clear? Now similarly they can give you some more patterns, right? So let us have a look on some more patterns and try to reach on to the conclusion or the relationships that they have between the digits. Here is another pattern, and you have to supply the missing terms that are missing here. So what we see is the first and last digit is always going to be 1. First and last digit is always going to be 1. Now what about the middle term? See, here the middle term is 2. Here the middle term is 2. Here the middle term is 3. Right? So what we do, we have to count the number of zeros. Okay, or we have to count the number of digits in between the two numbers. Just see how. 11 square is 1 to 1. Okay, then 101 square is coming as 10201. Clear? Then we have, see, when we had 10, the middle term is 2. Now 10101 whole square. How many zeros do we have? 2 zeros. So we have to reach to 3. That means 3 will become the middle term. So 1 and 1, the first and last digit are fixed, making 3 as the middle term. Now before 3 you have to add zeros, then you have to write 2, then you have to add zeros. So this will give you your answer. That means just see 10, 20, 30, 20 and 1. 10, 20, 30, 20 and 1. Similarly here, let us observe this one. 1, 0, 1, 0, 1, 0, 1 whole square. So 1 and 1, the first and the last digit are fixed. What about the middle term? How many zeros do we have? 3 here. Yes, so we will reach up to 4. 4 will become the middle term. Is that clear? 4 will become the middle term, and before 4 add zeros, then write 3 on both the sides, add zeros on both the sides, then write 2 on both the sides, add zeros on both the sides. So this will be the answer of this. That means we have to write 10, 20, 30, 40, 30, 21. Like this will be the answer for this one. What about the last one? We have been given the square number, a very long number, a very large number, and we have to find out it is square of what. So what is the middle term? You see here it is 5, right? Equal number of terms living on both the sides. We see that middle term is 5. So how many zeros are added between? That means instead of 3 or instead of 4, instead of 3 we have added 4 zeros, because the middle term is 5, one more than the number of zeros. So 1 and 1 definitely. Then how many zeros we have to add? 4 zeros. 0, 1, 0, 1, 0, 1, 0. So see 1, 2, 3, 4. There are 4 zeros in between, and the middle term is 5. Before 5 we have added zeros, before and after 5 adding zeros, then writing 4, again adding zeros, then writing 3, again adding zeros, then writing 2, again adding zeros, and the last terms are 1 and 1. Is that clear? So observing the patterns helps a lot, right? See, of this number, if you have to find whose square it is, it would have been very difficult and tricky for you. So just by observing this pattern, we are able to tell that this is square of which number. Clear? See, here is another question, and it's a really interesting pattern if you see. So they have given you 1 square plus 2 square plus 2 square is equal to 3 square. So we have to find out the relationship between them and fill up the blanks that are given here. You see 1 square plus 2 square plus 2 square is equal to 3 square. Right, 3 square is 9, and here we have 1 plus 4 plus 4, that is also 9. So that means this is verified. Definitely all of them are equal. Now what is the relationship? How are the terms filled? One thing that we can observe here is they are saying third number is related to first and second number. This third number, that means they are talking of 2. 2 is related to first and second number. That means with 1 and 2 it is related. How is it related? We multiply 1 and 2, then we get 2. Right? And what about the third and fourth number? Third and fourth number, we see if it is 2, it is 3, it is 1 more than this number. Right? Let us see if this relationship is there in the second one also, this one. Okay, so 2 square plus 3 square plus 6 square is equal to 7 square. So let us multiply 2 and 3. Is it giving 6? That means the third number is the product of first and second number. And is this number one more than this? Yes, it is there. That means third number is related to first and second by how? Third is the product of first number and second number. Right? That means 2 and 3, it is giving us 6. And what about this number? This number is one more than this number. So see here, 3 into 4 is 12. Square of 12 is equal to 13 square. Right? So we are getting one more than 12 here. 4 square plus 5 square. 4 5s are 20 will come up. Right? And here it is 21 square. 5 square, 30 square, 31 square. 5 should be multiplied with what? 6. So that we get 30 and equal to 31 whole square. Is that clear? Now here we have 6 and 7. So multiply 6 and 7, we get 42. 42 whole square is equal to then 43. One more than 42. Is that clear? So by observing the patterns, we can definitely fill the blanks that they ask us to fill very easily. So it depends on students now, on you. You know, everybody's perspective is different. Some may find a different relationship between the numbers. Some students may find different, but it should be, you know, applied to all of them. It is not that to the first line which is written 1 square plus 2 square plus 2 square equal to 3 square, it is applicable to it, and that is not, that relationship that you have discovered is not applicable to the second one. It should not happen. It should be applicable to all of them. Clear? Here is they're asking without adding find the sum. So we see here are odd numbers added. One property that we learnt is, if we add, okay, the addition of n odd numbers, or we can say the sum of n odd numbers, okay, starting from 1, we say the addition of n odd consecutive numbers. Consecutive odd numbers we are saying because we are not missing any odd number, we are taking one after the another. So the addition of consecutive odd numbers is equal to n square always, right? That means if you add 5 odd numbers, it will be equal to square of 5. Just to see here, if you add 1 and 3 is 4, 4 plus 5 9, 9 plus 7 16, and 16 plus 9 it is 25. So it is 25. How many odd numbers? 1 2 3 4 5. So directly you can write it is equal to 5 square 25. Right? So first one is done. In the second one, how many odd numbers do we have? 1 2 3 4 5 6 7 8 9 10. There are 10. So you just do the square of 10, you will get 100. This is the sum of these all odd numbers. You get it? Just count the number of odd numbers, do the square of that. So here 10 odd numbers are there, we do the square. So that means when you add all these 10 odd numbers, you get 100. You don't have to solve it. You don't have to add each number to another number. You just, count the number of odd numbers. Next one, I think you can do it easily now. 1 2 3 4 5 6 7 8 9 10 11 12. So we have 12 odd numbers. So it sum will be equal to 12 square, that is 144. So when you add these all the terms, you get 144. So without adding, directly using the property, we are getting the sum. And it was mentioned already in the question that we don't have to use addition, right? We just have used the property of square and we are reached on the answer. Clear? Here is another question. You have to express 49 as the sum of 7 odd numbers. Why only 7? Because 49 is a square of 7. So 49 will be written as, starting from 1. 1 plus 3 plus 5. Next one is 7. After 7 odd number is 9. Then it is 11. How many are these? 1, 2, 3, 4, 5, 6 and plus 13. When you add all these, you get 49 as the answer, right? So we have expressed 49 as the sum of 7 odd numbers. Now we have to express 121 as the sum of 11 odd numbers because it is a square of 11. So 121 is equal to 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21. Just see how many are these? 1 2 3 4 5 6 7 8 9 10 11, right? So this sum will give us 121. The addition of these odd numbers will give us 121. So this is how we express a perfect square. We know that 49 is a square of 7, 121 is a square of 11. Then only we can express them as the sum of odd numbers. Clear? Let's move ahead now. Here they're asking how many numbers lie between squares of the following numbers, right? So one thing that we have learned till now is, what is the property that we have learned? We have learned if we have two numbers, okay, we know that if we have two numbers, n and n plus 1, and we are doing the square of those two numbers, okay, so how do we find how many numbers lie between those two square numbers? So we are going to first find out the difference of these two numbers from the greater one, subtract the square of smaller one, and then subtract 1 from it. What do you get from here is, just see, n square plus 1 plus 2n. I have applied the identity of a plus b whole square minus n square, okay, and minus 1. N square and n square will get cancelled. 2n plus 1 minus 1. 1 and 1 will get cancelled. We have 2n. That means if we have two consecutive numbers like we have 12 and 13, and I have to calculate how many numbers lie between the squares of these two numbers, I just have to do 2 into n. Clear? So here in first question, what is here is 12 and 13. So n is 12 and n plus 1, that means 12 plus 1 is 13. We know that n is 12, n plus 1 is 13. Now how do we find the numbers that are lying between the two numbers? You need to do what? 2 into n, right? 2 into n is 12, so there are 24 numbers that lie between 12 square and 13 square. Let's verify it with one part, and the rest you can use the same property. So let us do 13 square minus 12 square and then subtract 1 from it. 13 square 169, 12 square 144 minus 1. We get 169 minus 144 as 25 minus 1. That gives us 24. Just see, we have verified it. 2n will give us the same answer as this. Right. So whenever we have to find the numbers lying between the square of two numbers, we have to just use 2n. Clear? Let's do the second part. In the second part we have 25 and 26. So here n is 25 and n plus 1 is 26. So how many numbers will be lying? Numbers that lie between 25 and 26 will be equal to how much? 2 into n. N is 25. 2 into 25, that comes out to be 50. So there are 50 numbers that lie between the square of these two numbers. If we try the third part, just to see 99 and 100, n is 99, n plus 1 is 100. So 2 into n is 99, gives us 198. That means between the square of 100 and 99, you do the square of 99, you do the square of 100, right? There are large numbers. You are not going to count each and every number and reach to the result that these many are the numbers that are lying between these two numbers, these two square numbers. We can just use 2n as the formula for finding the number of numbers that lying between the square of two numbers. Clear? That is 25 and 26. These are consecutive definitely. So this is how we find out. So our task is really minimized. We are at less calculation. We are saving our time. A lot of time is solved and the complex calculations are now resolved. Clear?